So this little paragraph down here says genes provide instructions for making the clotting factor proteins. That's what you guys read in your reading. The diagram to the left, what's up above, is an example of just one of hundreds of thousands of different proteins made in the cell of your body. So you guys have hundreds of thousands of these in your body. So what other types of proteins do you guys think your body might make? And so I want you guys to list your ideas below. Right? This can be anywhere from something that heals something in your body, something with your muscles, maybe something with your outside features. Just try to think outside of the box. Right? I'm going to start a 3-minute timer for you all. You may just have to write it down somewhere else because that is like, sorry. You may just have to write it down somewhere else. And then after you come back into it and it's not loading for you. Is anybody else having those problems? Okay. There's not much that you're going to have to put into this Google Doc. So if you have to come back to it at another time when it loads and just copy down what you have written down, then you can do that. I don't know what else you can do to get that Google Doc up. Alright, good. Alright, so make sure you have it down. We are actually going to put this in the periodic from what we said here in just a minute. Alright, so we're going to move on to activity 2 and 3. So we've kind of mushed these together. It is a hands-on, it would have been a hands-on activity in class, but we are going to use kind of an online tool in Google Docs slides. Okay? So we're going to review this investigation question first. We have some key concepts. We have some claims that we're going to look at and eventually pick today. And then you guys are going to review this activity. And then we have some more information on genes and then also another key concept. So we're going to be adding quite a few things to our digital notebook for these activities. All right, so for our investigation question today, we have the same question from Tuesday. Right, so how can organisms make different protein molecules for a particular feature? Alright, so this is where I want you guys to write your responses that you had for your warm-up into our peer deck. This is one of our questions today. So in the article you guys read about proteins your body makes to stop bleeding. Alright, so this means that if you get a scratch, something in your body, these proteins in your body, help to make a scab. Right, it helps to stop that bleeding. So based on your reading, what other types of proteins did you guys think your body makes? Right, while you guys are typing in Peer Deck, I'm going to put the link in the chat one more time to make sure everybody's in there. While you guys are typing this out, one example that I have that I've told the rest of the classes is that, yes, I'm going to just copy and paste your work into the Peer Deck. But one example that I have is with my knee. And so you guys know that I've been going to physical therapy this week and last week. And she told me that, well, I asked her why my knee was so stiff and why it was so hard to bend it. So you guys know that I tore my ACL, my MCL, and it's making it hard for me to have the same movement that I usually do. And so she said that there's some things going on in my knee that is helping to heal it. And so it's making it stiff to where I can't bend it as well as I want to. Okay, so there's something going on in my knee, so there's some proteins working that are trying to help heal it, making me not bend my knee. Okay, so make sure you're typing this out or copying and pasting your warm-up from the Google Doc into our Peer Deck. Okay, what do you mean enzymes? Blood structure, that's a good one. So blood reproduction. So if you lose a lot of blood, hopefully kind of recirculates and you get some more. Your body makes proteins for your skin to keep it healthy. So you have proteins that make your bones stronger, proteins that turn things like carbs into different things that are good for your body. Your hair, skin, and nails. Muscle proteins. So we were looking at something last week that a muscle in your thighs or your legs made you run faster. Okay, is this you? Is this you typing this? Are you looking at my screen?
That's me.
Oh, Emerson, that's you. I knew it was one of you guys.
Let me try to answer the guys. Oh, I've been looking in the Google Doc this entire time trying to find what we're doing. I'm sorry.
That's okay. We're just on the warm-up, and you guys could have just copied and pasted what's on the warm-up into the Peer Deck. Talking about proteins and what other proteins your body can make.
Sorry, I did it now.
You're okay. Emerson, this is a good one. So determining what hand we may be dominant with. How fast our hair grows. Somebody pointed that out last class. Proteins determine that. Proteins can help with body function, something with your bone structure, eye color, hair color, and everything in between. Right, so you guys saw, hopefully in the reading, that you guys have hundreds of thousands of proteins in your body, right? So we have a key concept before we get started. This is what we learned last class, and then we're going to look at it a little bit more with our claims today. So get out your digital notebook or open up your digital notebook in the tab, and we're going to write this key concept down in the chapter 2, lesson 2 slide. All right, so genes are instructions for proteins. All right, take about 30 seconds. Make sure you get that down into your digital notebook. About 10 more seconds. Genes are instructions for proteins.
Wait, I have a question. When did we do the temperature lesson 1?
That was on Tuesday. We may not have had any key concepts in there.
Do we need our Amplify open?
No, we're not doing it. We're in the Google Doc. You don't need Amplify open. Katie, we may not have had any key concepts down. That may be why you don't have anything for lesson 2.1.
I don't have anything for the blanks set.
So those, it's supposed to be important ideas. So you may not have anything down. Usually our key concepts go in there, and if we didn't have a key concept from last class, we didn't write anything down. That space is for you to, if we don't have a key concept, then that space is for you to write things down that you may have learned.
What do we do with the blanks on and the question on that page then?
I'll have to look at it here in a second. Once we get to activity 2 and 3, where you guys are on your own, I'll take a look at it and see what you're talking about, okay?
Okay, thank you. Sorry.
No, you're good. All right, so our investigation question, what I just showed you a second ago, ask how organisms can make different protein molecules for a particular feature. And so we know that organisms can make different protein molecules because they have different genes. So we all have different amounts of genes that do different things, like make our hair color, our eye color, our skin tone, something with our muscles, how we heal. But now we're going to try and figure out what role those genes play in making proteins. All right, so we know from this key concept that genes are the instructions for proteins. But our two claims that we're going to look at in a second are going to go a little bit more in depth on what role those genes actually play. All right, so we're going to use a model. Mr. Livingood has made us a model on a Google slide that we're going to do instead of doing a hands-on activity. Okay, so first, let's look at these two claims. This is what we're going to pick after we do our activity. So claim 1 is saying that genes provide instructions and they build the proteins. Right? So this is kind of saying that proteins are made up of genes. Right? Genes provide the instructions and they build the proteins. Right? So this in turn means that the proteins are coming out of the nucleus because our genes are in the nucleus. Right? This is the simulation that we looked at the other day. And so after we do our activity, I'm going to kind of give you a hint as to where these protein molecules are actually coming from in our simulation. So claim 2, it's still saying that genes provide instructions for making proteins, but they do not build the proteins themselves. So this is in turn saying that the instructions are sent out of the nucleus. These proteins are not coming out of the nucleus. They are used to build proteins in another location. This means that proteins are not being built in the nucleus. They're being built somewhere else, and the genes are providing those instructions for them. Right? So look at the differences between these two claims. We know that genes provide instructions for both of them. Claim 1 is saying that the genes actually build those instructions, and claim 2 is saying that something else is building those proteins. The genes are still giving those instructions to wherever else that they're being built. Okay? So each person's going to do activity 2 and 3 on Canvas. Right? If you go into today's module, this is what it'll look like. If you go to today's module, you scroll down here right under 2.2 evidence on genes, you'll see lesson 2.2 activity 2 and 3. And so you can go ahead and open that up and it will look something like this. I'll give you guys a few minutes or a few seconds to get there. And so once you open it up, the shapes on the left side are going to represent the building blocks of proteins. If we were in class, we would have used, I call them tinker toys because I used to work at elementary school, and all of the kids love to play with these tinker toys and kind of put them together. Alright, so the shapes on the left kind of represent these tinker toys and the building blocks of proteins. Alright, so here's my hint that I kind of talked about. We're going to take a look at the spider simulation to see where the proteins are actually coming from. So that's going to be after we finish the activity. So make sure you're in here. Okay, so I'm going to read the instructions while you guys are getting there. So the instruction below represents the DNA instructions for protein A and B. Right, you got protein A, you got protein B, and this blue space is where you're going to put your protein molecule. Right, so this next thing kind of gives it away. The ribosome constructs the protein. Right, drag the shapes to the area and construct the proteins. You can only use the shapes provided. Right, so you've got your different instructions, your 5 instructions for protein A and protein B. Now, your 2 questions over here on the right side, what caused the change in the shape of protein A and protein B? All you're going to tell me is which instruction is different, because they're pretty similar, but there's a certain instruction where it makes protein A and B so different. Now, the second question, don't get too confused with the second question. What would happen to the function of protein B? These are just shapes. You can't say that they have a function. You don't know where this protein exactly is. You can just tell me whether or not the protein B is going to have a different function or not. All right, so if they are shaped differently, if they're built differently, does protein B have a different function, or does it have the same function as protein A? That's the question I'm asking for that. Okay, if you can choose a claim by the end of this, you can place this green check mark to the side of one of these claims and turn it in. Okay. After this 10 minutes is up, we're going to look at the sim, and it might help you either change your mind, or it might help you know that the claim that you picked is correct. Okay, so during these 10 minutes, make sure you're working on that activity 2 and 3 in Canvas. Katie, I will take a look at the digital notebook.
Wait, how do we connect the triangles to the yellow thing?
Okay, let me go show you. So I don't want to do it on this page, but if you're looking at this screen, I made a copy of it. I just connected them with the corner of it. You don't have to line, it's kind of hard. Some of these won't line up to, you could turn it like this, or however you want, but some of these won't line up to, actually it will. If you want to do it like that, you can turn with this thing. Can you see what I'm doing on my screen?
Yes.
You can turn it a degree with that.
Thank you.
So make sure you guys are working on this. I'll keep this clock up. You've got about 9 minutes. It should be plenty of time for you to follow those instructions, make your proteins, and answer those 2 questions. feedback. I want you guys to pick the claim that you think is correct. Hopefully we are all on the same page. If you are not on our peer deck, make sure that you get there.
Oh, I'm sorry.
You're okay. It's okay, Katie.
Oh my god, I'm on the struggle bus today.
That's okay. Sometimes we all are. At least it's Thursday.
See, on Monday, I did not know I would do the rest of the week. This makes you feel any better. My Chromebook was broken for 2 weeks, so I missed out on 2 weeks worth of school. And midterm is literally tomorrow.
Oh, no, girl.
Oh, no.
If you need help, I got you.
Well, you guys turned in all your work except for, well, I've turned it in. I just don't think you mentioned it.
Okay.
But
I'll make sure to look at it. Grades are not technically, you don't have to post them until Monday. So you have until Monday.
all right.
So you're good. All right, so I'm going to look at our claims. All right, some of us are still confused. So claim 1 is saying that genes provide instructions and they build the proteins. So this is saying that it's coming out of the nucleus because proteins are made up of genes. All right, for claim 2, it's saying that proteins provide the instructions for making, genes provide instructions for making proteins, but they do not build the proteins themselves. This is saying that the proteins are getting made somewhere other than the nucleus and they're coming out of somewhere else. And so I'm going to show you guys the sim one more time. Some people already pointed out where the proteins are coming out of. Make sure you're looking. Are the proteins getting made in the nucleus? Or are they getting made in the ribosomes? Right? Ask yourself that question if you're still a little bit confused. See where the proteins are coming out of.
I have a question.
Yeah.
Okay. Genes are DNA, right?
They're part of your DNA.
Okay, so isn't DNA stored in the nucleus, right?
Yep.
So the nucleus is telling that whatever it is. Okay, makes sense.
Yeah. So it sounds weird that like genes are instructions and going like happening in your body, but these proteins are just being made somewhere other than the nucleus. And it gets into depth a little bit more as to why that is. We're not really going to look at that too much unless it comes up in the next chapter. And it's called translation and transcription, and it has to do with like mRNA, or like all that kind of stuff, and it goes into a lot of detail, but we're not going to do that right now. So hopefully you guys picked the correct claim. Most of us have picked claim 2, and you would be correct. All right, so we've got a key concept, and we've got one more vocab word that we're going to put in our digital notebook. All right. So this key concept talks about a gene version. And if you're confused about what a gene version is, if you look over here, if you're looking at my shared screen in our simulation, this is the gene version. So this is what you guys had for homework the other night. Hopefully you guys looked at it, but you were changing the gene version. And so that's just a particular gene, and we'll get that definition of gene version here in a second. So each gene version provides a unique instruction to make a specific protein molecule in an organism's cells. All right, so last class, I think it was last class, you guys should have seen if you change that gene version, you change that specific protein molecule, which in turn, if you change both of those, you change the trait of the spider. All right, so if you added, so there was like F1, F2, F3, and those all stood for different protein molecules going into the cell. And if you change those for the spider silk, you may have changed it from like a low spider silk to a high or a medium spider silk. So make sure you get this key concept down in your notebook, and we'll move on here in about 15 seconds.
Shanks, I need to go let the dogs out for my dad. I'll be right back.
Okay. Alright, so make sure you get that key concept down. We have a vocab word, which is gene version. I'm going to put this in the chat so that you can write it down, just in case you miss it. Katie had to go let the dogs out. So, gene version. So, I was showing you that gene version was up in the top right corner of our simulation. So, it is a specific form of a gene that provides instructions for making a particular protein molecule. And then I'll go back to it in a second. Just get this vocab word down first. Alright, I put that in the chat. I'm going to go back to this so you guys can see it. Make sure you get it written down or typed out in your digital notebook. So each gene version, which is a specific form of a gene, provides a unique instruction to make a specific protein molecule in an organism's cells. Brandon, let me know when you get done with that. Perfect. Alright, so I told you guys we're not going to be doing mutations today just because I think it'll take a little bit longer and I want to spend a little bit more time tomorrow, probably about 15 minutes going over it. So this is one of the last slides before I tell you about the homework. So genes are instructions for making proteins. This is kind of connecting what we learned about genes, what we've learned about protein molecules, gene versions. So genes are instructions for making proteins. And this determines the trait of the organism. So the different genes you have, the different proteins you have, the different types of traits that you have. So brown hair, blue eyes, the types of muscles, how you heal, that kind of stuff. And so there are different versions of each gene. Each gene version is a unique instruction for making a specific protein molecule. And then you guys read in the article on Tuesday that different versions of genes can also be called alleles. Alright, so we're going to skip our mutation stuff right now. And so since we are skipping our mutation things, we are not going to do the weekly check-in today. I'm going to assign that tomorrow, and that won't be due until probably Tuesday before class. Okay? So for your activity 5, you're going to watch the Scottish Fold Cats video and then answer the question. So on your Google Doc, you have a link that's going to take you to the video. But what it's going to do is it doesn't take you straight there because I couldn't get a link that will take you straight to the video. It's going to take you to the homepage of lesson 2.1 or 2.2. And so when you get to this homepage of lesson 2.2, you see these digital resources, and I have this in instructions on the Google Doc. Okay, you will see something titled "Video Mutations and New Traits," and you will see this video pop up. And it's about Scottish Fold Cats. All right, so in that Google Doc, you have one question to answer after you watch that video, and it is, how can a mutation result in a new trait, as seen with the Scottish Fold Cats? Right, so this is kind of it's going to get us started on talking about what mutations are. Okay, so that's the only question you have After you watch that video, you can get it done here in the next 10 minutes and you don't have to worry about it. All right. So other than that, we're not doing the weekly check-in until tomorrow. That is all that I have for you guys today. If you have any questions, let me know. If you need any help on missing assignments, let me know. All right, you guys have a good rest of your Thursday, and I'll see you tomorrow. See you, Lexi. What'd you say, Katie? Sure.